Hello friends, welcome to my YouTube channel AI Hack by AK. In this particular video tutorial, I'm going to tell you about the sequential feature selector and the permutation feature selector of Mlxtend package. So I found this Mlxtend package very useful while doing my data scientist job because it gives a lot of options which are better than the scikit-learn. Now, why we do feature selection? So, for example, if you have around 100 variables in your data set, or after pre-processing, you have found that, for example, after making dummy variables and after transforming the numerical variables and all that, and after deriving the variables from some other variables, you have found that you have around 100 or 150 variables. So you just cannot put all those variables into the model, and then you cannot just present this to anyone and say that, okay, this is how the my model performs. Uh, so the feature selection method will give is a part which has to be performed before the final modeling stage, where you basically select for example, n best variables, which explains your target variable, variation in the target variable, and then you build the model on those n variables. So this n could be top 10 best variables, top 20 best variables, top 30 best variable, depends. So this is all about feature selection, and now I will go to the Mlxtend and I'll show you how this sequential feature selector and the permutations feature selector works. Uh, so we have to just install the Mlxtend package. I have already installed, so I'll not do this. So for installing, you can just basically do, pip install Mlxtend. So so this is, so this is already done. I've already installed it. Now, another thing is that why we should use the Mlextend features sequential feature selector, uh, considering that we already have a recursive feature selection in scikit-learn. So the reason is that I that uh, basically is that RFE is computationally less complex using the feature weight with linear models of feature importance and tree-based algorithm to eliminate feature recursively. But in sequential feature selector, you can define your performance metrics on which basis you want to select your features. So for example, if you go here So for example, if you go here, you can use accuracy as your feature selector, R square for your regressor. You can also use F1 precision recall, ROC curve for your metrics for the feature selection. For regression, you can use mean absolute error, mean squared error, negative mean squared error, median absolute error, etc., etc. So there are a lot of options are available in sequential feature selector from Mlxtend package compared to your recursive feature selector in scikit-learn. Like so scikit-learn is basically based on some linear models for the regression and a tree-based algorithm to eliminate features. Compared to sequential feature selector, which gives you variety of option, considering whatever you want to consider. You want to consider accuracy, R square, accuracy, ROC curve, precision, recall, everything is there. So it depends on you. So that is why I basically prefer using Mlxtend. So now for that Mlxtend you have to use Mlxtend, you have to import Mlxtend, and from Mlxtend.feature selection you have to import sequential feature selector. I've imported is as SFS. And also it also gives you it gives you some plotting capability also for the for the features. So you have to import like mlxtend.plotting. In plotting, you have to import the plot sequential feature selection as plot SFS, and now I'll run it. So this sequential feature selection has two methods, which is called sequential backward selection method and sequential forward selection method, which is basically the same as you have learned in the regression, the forward selection and the backward selection. So in backward selection, starts with all the features in the data set, and then it evaluates the performance of the algorithm, and the least significant variable is removed one by one until a certain criteria satisfied. So certain criteria, it means that unless you specify how many features you want. So unless, for example, if you have specified that you need 10 features, so if the 10 features has been satisfied, then it stops there, and your top best 10 features, you will get it. The sequential forward selection is completely opposite to the backward selection. So in forward selection you initialize with an empty set, and then the features, so the best features is added first, and it keeps on adding the second best, third best, and the fourth best, fifth best, and that and all until a certain number of features that you want is being completed. So that is the sequential forward selection process. Now we'll see the what are the options we have when we do the sequential feature selection. So this is the estimator. So estimator may be your classifier, your regressor that you want to perform on the data set. K features is the number of features you want to select. Forward is equal to true is basically if you need to do a sequential forward selection. If you make it false, it will do the backward feature selection. Apart from that, the scoring is none. So scoring you have to, uh, if you want a different scoring, then you have to specify. Otherwise, for classification task, it will take accuracy as default and R square for regression as default. Rest of the features, I don't think it's important. So one more thing is that cross validation, if you want to perform, so automatically it will do the so the default is five-fold cross validation. Now I'm going to demonstrate the classification task here. So I'm just loading the iris data set here, and if you see the iris data is like this. There are four four variables in it, iris data set, and my classifier is KNN classifier. Now now I am just doing the feature selection here as I have in explained it here. So I am here giving the SFS, and then I'm giving my estimator, which is KNN. I've already defined it here. Here, number of features I want three. So there are four variables, but I want only the top three best variables. Forward is equal to true because I am going to do the forward sequential feature selector. Floating, you can leave it for now. It's not that important. Scoring, I have specified I want accuracy scores, and the twofold cross validation, I can make it default 5 here. And I've given my feature names here. If you want, it's not necessary, but in the output, if you want to see your feature names instead of the index number of features, then you can specify your feature names here. And once you run that, once you run this thing and you run that, then you have to when you have to fit it on your XY, and then so it basically have done that. Your it has given the output for the top three best features. So in the first, it has taken one feature. Second, it has taken the two or three features, and in the third, it has saying that the feature number with index 0, and feature number with index 2, and feature number with index 3 is the best features. Here it has left out the feature number 1, because uh, because when we are saying that we want three best features, so it has taken the three best features on the accuracy matrix that has been done. Now you can also do it in a data. You can also convert it into a data set here, so you can see that, like, it will give you all the accuracy metrics here. So the feature index third, it has come first in the data it has been taken first, since we are doing the forward sequential transformer, so it has come first, and it has given the name, the petal width. Second, it has taken the second the second variable in it, and then you can see the average score, what is the cross validation score here, and also it is giving you this confidence interval boundaries, so which basically say that with how much confidence you can say that this accuracy will be achieved if it is performed, you know unseen data set. The standard deviation of the CV score, and the standard error of the CV scores, which basically can be used to gauge like how it is performing on the standard errors. Average score is basically the average of all these CV score five-fold cross-validation scores. So as you can see here, in the end, it has taken the it has selected the top three uh, features, and it has given us the accuracy of 95%, right? If we have selected the top two, then I think it would have stopped here with 96% accuracy. But since we have explicitly told the algorithm that you want three features, so it has selected the top three features in it, which are sepal width, and petal length, and the petal width. You can also plot it by using the plot SFS, which we have imported earlier. So as you can see here, it will give you very good plot, which shows that like with one features, two features, three features, and since the fourth features, with all the four features, it will give the 97.5% accuracy. But since we are using three, it is giving us around 96% of accuracy. The same thing can be performed for the regression task also. So here I have loaded the Mlxtend data set here, and I am scoring. Again, I have changed it. The default for regression is R squared, but I'm giving here is negative mean squared error, because it's user defined, and you can give it whatever you want depending your requirements. So as you can see here, I have given the same thing. SFS linear regression is my estimator. Top 13 features I want. Forward is equal to true. Scoring negative means gone, and CV is the cross validation I want. So I have basically uh, combine the code, and you can see here, this is the nice graph that you can see here about the negative mean squared score. So this is all about your sequential feature selector, which I think it's a way better than your recursive feature elimination, which is a part of scikit-learn. Because first you can give um, your user-defined metrics for selecting the features, and second is that it also gives you a nice plot to understand what is happening with the feature selection uh, and all that. So this is so that is why I prefer this Mlxtend's feature selection, sequential feature selection method. And now we will go for the feature importance permutation feature selector. This is basically b- m- this basically is not you'll not find it in scikit-learn, but while we were working in R and all that, when you do random forest, so this is the part of that random forest packet where you can do the feature importance through permutation. So what is the feature importance with permutation? So what it does is that it takes a model and it fits the model into the training data set, and it then estimates the predictive performance of the model on an independent data set, which is basically cross validation, which is basically validation data set. And it takes then it records like how much accuracy it is getting. Then what this algorithm does is that it takes each of the features and then it basically shuffles the values in that particular feature or column. So for example, if you for example, if there are 10 features, so it will take one feature and then shuffles the value of that particular column. So the column values will be jumbled up, and after then the model is fit again, and then it is tries to see like how much performance is decreasing. So for example, if earlier you are getting an accuracy of around 90%, but after jumbling a column you are getting accuracy of, for example, 80%. So that will be the measure of the importance of that particular column. And it so so this algorithm does it for every column, and more the decrease in the accuracy after shuffling up the values in the column, the more important it is. So because it basically says that like shuffling up the values in the column, it basically decreasing the accuracy. So so more the decrease in accuracy of that particular column, the more important the variable is. I think you have got the idea what I'm saying is. So this is all about the feature importance. So how it is implemented with Mlxtend. So you have to apart from that you have to import the feature importance permutation from mlxtend.evaluate package. For this demonstration, I have imported the support. I've imported the SVC and the support vector classifier, and then I've imported the matplotlib, and and now I am building a, um, a classification data. Okay, and then I'm building the classification data, and here I am splitting the classification data into train and test, because I want to test it or test my permutation on this test data. So I have done that. Now I am just taking the random forest classifier with 250 trees, and I'm fitting it, and let's see. So this part I have done, it is just giving me what is the accuracy is when we use the random forest classifier. So random forest classifier, as you know, it always gives you the feature importance, which is based on the Gini coefficient. So this accuracy that you can see here, it is coming from the Gini coefficient. So test accuracy is around 95% and the training accuracy is around 100%. Sorry, training accuracy is around 95. Now, now, now we want to do it on the permutating the column. After permutation the column, how the accuracy is coming for each of the columns. So now you have to do, so I'm creating two variables here. So this is the important values and it is the original values. And I'll explain you what are these, and then after this you have to do this feature importance permutation, and after that you have to specify the predict method. So forest dot predict, it will be your predict method, and you are predicting it on the X test and Y test. Your metrics will be accuracy and number of rounds will be 2. Number of rounds will be 2 means that it will do it it will do it uh, 2 times with different random seeds. Okay, so why means it will select a different data set each time, right? So I have you know so it has been done. Okay, so the X test and Y test you have taken, and then I'll do it. So as you can see here, it is giving me the feature importance of all the 10 variables which are in it. So as you can see here, it is the feature importance when using only the random forest, and this is the feature importance of the variables after the permutation has been done, and after the permutation has been done and then accuracy has been um, collected, and then after that the uh, variable with the highest drop in accuracy after permutation has been selected here. So you can see that the same variables is giving 26% here, it's a 28%, 27%, so 20, 35% and all that. So as you can see here, the permutation accuracy has been given here. Now, these are the values of important wall. What is this original values? Original values basically gives you the number of rounds. What is the what is the you know what is the importance is generated after each round. So if you make it 3 here, if you make it 3 here, it will give you 3 columns. So first round, this accuracy has been generated. Second round with different with different seeds, this accuracy is generated. In the third round with the different seed, this accuracy has been generated. And the the average of all these will get into this. So if I do average of point 3.24 and I will do average of this divided by 3.2599, which is equivalent to 0.26. So as you can see here, this is how it is. This is how this thing has been done. So I believe, like, you have enjoyed it, and if you have any questions and want to uh, if you want me to talk to any other topic, then you please suggest me in the comment column, And please do like and subscribe to my channel and hope you have enjoyed this tutorial. Thank you very much. Bye, see you next time. And also I have given the references of this file, of this material from where I have taken all these things. I will be uploading this file to my GitHub account, so you can go ahead and check out and you can learn more. There are many other methods in each of the topics, so you can go and learn about it. And thank you very much. Please subscribe and like my channel. Thank you all.